Hello and welcome. This is Science Visualized, and today we're looking at organic chemistry reaction called Grignard reaction. So Grignard reaction, anytime you see Grignard reagent, it's usually in the form of alkyl magnesium halide, where the R group could be any alkyl group and the halide could be fluoride, chloride, iodide, or bromide. So an example of that will be methyl magnesium, bromide, or iodide, or fluoride, or chloride. Or you could have ethyl. Remember, ethyl group has 2 carbons, so CH3CH2, magnesium, say, iodide. You could also have propyl, has 3 carbons, so 1, 2, 3, and then connected to magnesium, and this time around, let's say, chloride. What's really important with Grignard reagent is that they give very good nucleophile, where you cleave the carbon magnesium bond, and therefore you end up generating a CH3 minus nucleophile. So very good nucleophile. Same thing with ethyl magnesium iodide. Now you cleave the carbon magnesium bond and you end up with CH3 CH2 minus charge on the CH2. Same thing with the propyl magnesium chloride. You cleave that bond and you end up generating the minus charge on the 3rd carbon. Another example is phenol magnesium, let's say fluoride. And in that case, you cleave the carbon magnesium bond, and therefore you end up generating the minus charge on that carbon. So that becomes a very good nucleophile. The question now is, how do we prepare Grignard reagents? In order to prepare Grignard reagents, you start with the corresponding alkyl halide. Remember, the halide could be any of these here. And then you react that with magnesium metal in ether. So it's very important. You must use an ethereal solvent, and we'll see what are examples of ethereal solvents. And what ends up happening is that the magnesium ends up inserting between the alkyl group and the halide, and therefore you end up with alkyl magnesium halide. So for example, if you started with this as the starting material and then reacted that with magnesium in ether, you now end up inserting the magnesium between the carbon and the fluoride. So you end up with that as the Grignard reagent. Now let's look at reactions of Grignard reagents. Number 1, reaction with alkyl halides, RX. So for example, if you have an alkyl magnesium bromide plus propyl iodide, remember you end up generating R minus nucleophile, which then will carry out an SN2 displacement of the leaving group iodide. And as a result, you end up with that product, but now the iodide has been replaced by the alkyl group. So you end up forming what's called carbon-carbon bond. So right there, carbon-carbon bond. Let's look at more examples. So in this case, we are using benzyl magnesium chloride and reacting that with cyclopropanyl chloride, so which is actually an alkyl halide. Remember what we saw before is that you cleave that bond and you end up with a negative charge on that carbon, that CH2 carbon, and then that will substitute the Cl group, and therefore you end up with the Grignard displacing the Cl, so you end up with a new bond there. And as you can see again, we formed a new carbon-carbon bond. Reaction number 2 is with aldehydes and ketones. So aldehydes has an alkyl group, carbonyl, and then hydrogen, while ketones will have an alkyl, carbonyl, and then a second alkyl group. In this case, the Grignard reagent will react with, say, an aldehyde. Remember, you end up generating a minus charge on the carbon connected to the magnesium, and then that ends up adding to the carbonyl carbon, and then the electron pair from the double bond will flow to the oxygen to form an O-. Now you have the O- there. And then the last step in this reaction mechanism is quenching by adding either water or under acidic environment, so you end up adding a proton, and that becomes an alcohol. So you end up forming an OH from the O-. Therefore, we'll say that Grignard reagents react with aldehydes or ketones to give alcohols. So if it reacts with an aldehyde, it has only one R group, and therefore you end up with a secondary alcohol. If it reacts with a ketone, you're starting with two R groups, and therefore you end up with a tertiary alcohol. The next reaction is reaction with carboxylic acid derivatives, for example, esters, acid halides, and acid anhydrides. So we're going to generalize them as alkyl group, carbonyl, and then use a Y for the leaving group for the carboxylic acid derivative. So starting with the Grignard reagent plus the carboxylic acid derivative. Now the first step is, remember, we generate a nucleophile from the Grignard, and then that nucleophile will add to the carbonyl. One of the bond electrons will flow to oxygen to form O-. Then that will give what we call tetrahedral intermediate. And then the last step is the collapse of the tetrahedral intermediate by the electron pair coming back to form a double bond, and then the Y group will leave. It's a good leaving group, and therefore you end up with the original alkyl group from the Grignard, and then that R from the carboxylic acid derivative, and now we have the new carbonyl and the Y group left, so plus Y-. And basically what you end up with here is a ketone. The reason is because we have two alkyl groups, 1 and 2. So in summary, we can say Grignard reagents reacts with carboxylic acid derivatives like esters, acid halides, and acid anhydrides to give ketones. The last reaction that we will look at is with nitriles, and nitriles' general formula is RCN, so also written as RCN, where you have a triple bond between carbon and nitrogen. So in this case, we'll start with a Grignard reagent plus a nitrile, and as we have seen, the first step is the nucleophile will add to the nitrile carbon. Then at the same time, one of those bond electrons, that's 2 electrons, will flow to the nitrogen. Remember, nitrogen already has a lone pair of electrons. Then you'll end up with R connected to that carbon from the nitrile and that alkyl group from the nitrile, but now you have double bond to nitrogen with a minus charge on nitrogen. And then the last step is addition of water, And basically what will happen is that you end up cleaving that and replacing the nitrogen with an oxygen. So basically you end up with a ketone. So in summary, we can say that Grignard reagents react with nitriles to give ketones. Thank you very much for your time. If you enjoyed this presentation, please like this video and also subscribe. Bye.